Section 7.4.27. In a recent poll, 46% of survey respondents said that if they only had one child, they would prefer the child to be a boy. Suppose you conducted a survey of 150 randomly selected students on your campus and find that 82 of them would prefer a boy. Complete parts A and B below. Okay, so in part A it says use the normal approximation to the binomial to approximate the probability that in a random sample of 150 students, at least 82 would prefer a boy, assuming the true percentage is 46%. So the first thing we need to do is, in order to use a normal distribution to approximate a binomial probability distribution, the following must be true. We should have n times p times 1 minus p must be greater than or equal to 10. So we know that n is equal to 150 in our problem, and we know that p represents the percentage of 46%, which is 0.46. So let's go ahead and plug that in. So we have 150 times 0.46 times 1 minus 0.46 must be greater than or equal to 10. And so we get 37.26, which we know is greater than or equal to 10. So the binomial random variable x is approximately normally distributed with a mean of the following. So the mean is going to equal n times p, and the standard deviation is going to equal the square root of np times 1 minus p. Okay, so let's find the mean. So the mean is going to equal 150 times 0.46, which gives us a mean of 69. And the standard deviation is going to be 150 times 0.46 times 1 minus 0.46. And if we take the square root of that and round it to 3 decimal places, we get 6.104. So now what we want to do is we want to be able to then find the probability that at least 82 would prefer a boy. So what we want to do is we want to find the probability that x is at least greater than 82. But again, we're using an approximation. So if it's an approximation, we're looking for the probability that x is going to be greater than or equal to 81.5. So if we create our bell curve, we're looking for the following. We know that our mean is 69, and we want to find it to be greater than 84.5. So what we want to be able to do is now we want to be able to find the z-score. So we're going to take 81.5 and we're going to subtract the mean, which is 69, and then we're going to divide that by the standard deviation, which is 6.104. And so therefore the z-score rounded to 2 decimal places is going to be 2.05. So now when we convert this into a normal curve, we know that our mean now is 0. We know that our z-score is now going to be 2.05, and we want to find the area that's to the right of that. So now we want to find the probability that z is going to be greater than or equal to 2.05. So that means we're going to take 1 and then subtract the area that's to the left of 2.05. So if we come down here and we look at 2.05, we can see that we get 0.9798. So it's going to be 1 minus 0.9798, which gives us a probability of 0.9798. 0.0202. So again, if we wanted to do this on a calculator, we're going to go to normal second distribution to normal CDF. We know that our lower bound is 2.05. We know that our upper bound is 9999. We know that our mean is 0 and our standard deviation is 1. And then hit enter, and you can see rounding to 4 decimal places. That gives us the exact same area that we just got. And then if we use the curve here, again, we're looking for greater than, so we're going to go back to the standard. We know we're looking for it to be greater than, and we want it to be greater than 2.05 with a mean of 0 and a standard deviation of 1, and therefore there is the same area that we got in those two results. Okay, and let me copy that again for the calculator. Okay. And so therefore, answering this question, we can say that the probability that at least 82 students would prefer a boy is 0.0202. So now, do these results contradict the poll? We want to be able to explain that. So we can say that, recall that an unusual event is an event that is 2 or more standard deviations from the mean. That is, it has less than a 0.05 chance of occurring. Since the probability found in part A is less than 0.05, the survey results are unusual. So you're going to use the fact that your results are unusual to determine if they contradict the poll.